Alright, so now let's talk about MapReduce in Pyspark. So we'll start by just, doing the previous step of creating some configuration, setting the app name, which you said is kind of like our database, setting master, which remember this is what is the location of our cluster that we're connecting to. Here it's locally on our computer, and here we specify the number of cores that we're allocating, and remember that's going to determine the number of partitions in our RDD. Then this Spark context, remember that's kind of like the entry point. It lives on the driver, so this is how we directly interact with our Spark cluster, and then we can get or create that Spark context. So essentially we're getting or creating a connection to our Spark cluster through this context. All right, now we can create an RDD. So we'll start with just a list of movies in Python, and then we'll do sc.parallelize and pass through that Python list. And if we do now rdd.getNumPartitions, I think that's the command, you can see that there's two partitions, meaning that if we do any queries, they'll be operated twice in parallel across these two partitions. And that makes sense because we allocated two cores, right? So one partition for each core. And now let's try to do let's do a simple filter, I guess. So rdd.filter lambda movie. So we'll go through each of these movies, and we'll select where movie is equal to, let's say, Pulp Fiction. All right, and then we'll do that collect at the very end. So let's think about what happens when we do that. This step is called essentially, I guess it's two steps. So first, maybe I can make this, no, I can't make it bigger. Okay, so when we created the RDD, right, we're splitting it up across these different partitions. And then if you think of what happens when we filter, we are, as we mentioned before, we're essentially calling that filter method on each one of these partitions, looking for the specific movie. This step is called mapping, all right, because mapping is when we're performing the same task in parallel across these different partitions. The reduce part is then sending back the results. Okay, we're reducing by sending back each of the matching results. Here there's just one, it's Pulp Fiction. Now something like this, it's actually, it's pretty efficient, but sometimes our queries are not so efficient. There's something that can, I don't know if it's going wrong, but something to at least be aware of. And that's shuffling. So shuffling occurs when an operation, like a query, is going to require us to send our data across different partitions. So we're actually going to be, and we'll see in a second, transferring data from one partition to another. And remember, these are different computers, right? So transferring data from one partition to another means we might have to transfer it from one computer to another, and that can take some time. Right, so sending data from one node, meaning a computer, to another is time intensive, especially because the bridge between these computers, like the network, this can be pretty thin. So if you're sending a lot of data, it can really be constrained here in doing that. So when does shuffling occur? All right, so let's say we have these lists of movies, and we convert it into my RDD. And now here's a command that you may perform a good amount that can cause shuffling, and that's group by. So this time we'll take our, we'll try to take our movies RDD and group it by the first letter. Okay, so group the movies by the first letter. And before we do that, let's think about what occurs there. So imagine that we have these partitions of Shazam and Minari, and then this is in our partition 2. Then we have Casablanca and Michael Clayton in Cesario. So if we were to group by the first letter, group our movies by the first letter, well, this means that we have to send Minari over to partition 3 and probably send Casablanca over to partition 2. So there's a lot of shuffling that could potentially occur through this grouped by. It doesn't mean that we shouldn't do it. It's just something to be aware of, because if it's possible for us to avoid it somehow, we should. So here we do the group by, we do lambda movie, and I'll say group it by the movie's first letter. Okay? So this, if we look at the results, we have to call this collect thing. You see this last thing as a result iterable? I just want to prove to you that this iterable is essentially like a list that we still need to unpack. So let's just take a look at it. So we'll do map lambda, and this time we're going through this tuple. Okay? So I'm just going to refer to this as a group. And for this group, we will still return a tuple. So I'll select the first element and just return that. And then the second item in the tuple will just convert to a list. So just do list of group square bracket 1. Let's see if that works. I thought I might have had something extra here. So I think it might have just been, it needs to be on the same line. All right. So you can see it, right? We did perform the group by. Now, as we said, that we believe results in shuffling. What's pretty cool is you can actually see this if you go to the Spark UI. So I'm just typing in SC, which pulls up a link to the Spark UI. And it's always located, I think, on this 4044 port. So this has a log of the steps that we performed. Okay? So you can see right here's my group by. And let's click on the group by. Okay, so you can see the steps involved, and we'll talk more about this in a little bit. But we started with our RDD, and then we performed a group by to group the movies by these different by the first letter. Now down here, these are called tasks, and again we'll talk a little bit more about this. But these are telling you how long each task occurred, and notice that they're overlapping. This is because we're working with an RDD and we're able to perform these steps in parallel. Okay, so this computing time, that's performing some of the queries. The issue is this yellow, which is the shuffle time, and that's generally what we try to reduce. Now, shuffling did not take much time in this case because everything's on my computer, but you can imagine in a cluster this can become more expensive. All right, so in the next lesson we'll dig even deeper into how RDDs work and how they try to be efficient.